Welcome to onalevelsacademy.com. So today we are going to focus on this topic. It's called free radical substitution reaction. What is it? It is a reaction between a halogen and an alkane. Remember that alkanes are generally unreactive. The very few reactions that they show, one of them is free radical substitution. And one of the conditions of this reaction is sunlight. Why is that? Because generally alkane doesn't want to react, but when sunlight falls on chlorine molecule, it is broken down into two radicals. What is a radical? A radical is a species that contain that is formed when a covalent bond is broken into half. It's broken equally. So it's called homolytic fission. So if I break the bond ClCl, chlorine, ClCl, in the middle I will get two free radicals. And these free radicals are very, very reactive. And they will attack an alkane molecule to do the reaction, which generally an alkane doesn't. An alkane doesn't want to react, but when a free radical comes, it reacts. And generally, when it reacts, it takes out one hydrogen from the alkane and substitute a chlorine in place of that. So that's why it's called substitution reaction, because it substitutes one hydrogen with chlorine. So it's called. Why is it called free radical substitution? Because of the presence of free radical. Now let's see the mechanism in this 3D animation. You can see that sunlight is falling on in the first step, which is called initiation reaction. The free radical is formed that attacks the alkane, forming an alkyl radical, and this is called a propagation stage. And in that stage, the alkyl radical is formed. That means a new radical is formed. Once the alkyl radical is formed, it can attack another chlorine molecule to take one chlorine from it and make another chlorine radical. So you get more chlorine radical in this stage. Now in the termination stage, all the available radicals will react with each other to form compounds that are not radical. So radical plus radical will produce a normal compound. For example, chlorine radical will react with another chlorine radical to form chlorine. Chlorine radical with an alkyl radical will form alkyl chloride. An alkyl radical will react with another alkyl radical to form a longer chain alkane. So in the termination stage, all the possible products can be seen. One thing that we need to remember, that in this free radical substitution, we not only get a substituted alkyl halide from alkane, but also we get a longer chain alkane. So this is very important.